request and he got the ARP reply. Okay. One thing you might notice that it is showing it as lost because Windows has this particular filter that it blocks packets which it receives as from two broadcast address, and the IP and MAC address don't correspond to each other. So yeah, this can be skipped by packet tunneling through attacker. No state maintained in it. So whenever I say that this particular machine has this particular MAC address, it is done. I mean, there is no way to prove that I'm right or wrong because it is stateless. So typically nodes tend to cache all the ARP replies sent to them even if they had not sent an explicit ARP request. We call this a gracious ARP. And even if nodes do not update on gracious ARP, the attacker can make the nodes update their ARP with desired IP MAC using several techniques. One is using a spoofed ICMP echo request, where you spoof the MAC address of the sender. So as a reply, it is a ARP optimization, it updates its ARP cache. So there are several techniques using which you can force a desired IP MAC binding into any machine which is not ready to accept it. So this is how traditional MITM by ARP spoofing works. So firstly, let me tell you why I call this the real stealth man-in-the-middle attack. It happens that there is another paper in conference which goes by the name Stealth Man-in-the-Middle Attacks in DOS Channels. So essentially the authors and I had tend to disagree upon the term of the man-in-the-middle attacks. So according to them, the man-in-the-middle attack is any attack which a third person tries to hamper a network and degrade its performance in any way. Whereas my definition goes as you must be able to intercept the communication. You must be able to know what communication is going on between Alice and Bob. Okay, so that's the reason I called it the real stealth man-in-the-middle attack, because I don't consider that as a man-in-the-middle attack. So this is the traditional MITM by ARP spoofing, as we all know. Let's say this is Alice and this is Bob, and IP of Alice should be actually mapped to MAC of Alice. But the attacker forces his MAC address onto Bob, so that the IP binding of Alice is mapped to MAC of attacker. And similarly, the IP of Bob is mapped to MAC address of the attacker at Alice. So in this way, whenever Alice wants to talk to Bob, she sends all the packets to the attacker, and attacker tunnels it and it typecasts it replaces the MAC address of Bob with the attacker with that of Bob, and it sends the packet. So these two parties will be thinking that they are communicating with each other directly, but in reality, attacker is there in between. So why is traditional MITM by ARP spoofing a problem? By problem, we are considering the attacker's perspective. So attacker is visible to the network administrator. Why? Because attacker leaves his current MAC address at Alice and Bob's ARP caches, and attacker's MAC to switch port binding is fixed during the attack. So which leads the administrator to the attack surface physical location. So when you consider a wireless network, the scenario is very simple over there because the node can be anywhere. So that is inherently stealth. So let's talk about the more complex scenario, which is a wired network. So when you're talking about wired network, when an attacker connects himself to a port of the network, so his port to IP MAC binding is fixed in the network switch. So assuming that the network switch is a managed one, since the MAC address of the attacker is recorded at Alice and Bob, in case of any suspicion from Alice and Bob, they can report to the network administrator, and he can pinpoint the attacker that okay, this is a particular port from which is coming, so the attacker must be around here somewhere. So that is the problem with traditional MITM. And yeah, this is what happens. MAC of attacker is at port 2. So whenever Alice reports to administrator that I think I'm having a suspicion that someone may be tampering my network, so MAC of attacker is directly mapped to port 2, and bingo, we got the attacker. So what is the idea behind the stealth man-in-the-middle attack? So we believe that if we leave a broadcast MAC address at Alice and Bob's ARP caches, there will not be any broadcast map to switch port binding in the network, right? That is because broadcast is something which corresponds to the entire network. So there is no specific records as to this broadcast address maps to no one. It maps to pretty much everyone. So our plan is to replace the attacker's MAC address with broadcast address. So the attacker can sniff on the broadcast packets. So whenever the communication between two parties is public, anyone can listen to the communication. Previously, what happened was that when Alice and Bob are connecting to each other directly, talking to each other directly, when you are butting in between. So as a result of this, it can be caught. So whenever the idea is that when two speakers are speaking publicly, anyone can tap into the conversation. So this is how it works. It looks like the IP of Bob is mapped to MAC of broadcast MAC address, and MAC of IP of Alice is mapped to broadcast MAC address. So attacker's MAC address is invisible to Alice and Bob. Okay. So what happens is that Alice and Bob tend to communicate with each other because they have since broadcast packet they capture it. So they have a connection, and actually technically what happens is that attacker must tunnel the broadcast packets and put in a specific MAC address or some random address. It doesn't matter, because in machines like Windows it tends to block the packets which have broadcast as source. So the attacker gets a copy of all the conversation between Alice and Bob. Okay. So what are the pros of this attack? The attacker's identity is completely hidden. So the broadcast MAC address maps to no one, and no packet tunneling through the attacker's node, and thus faster than the traditional man-in-the-middle attacks. In traditional man-in-the-middle attack, the attacker must capture each and every packet, and he has to change the packet, and he has to reroute it to Bob. So as there is no tunneling in this thing, so it is considered to be generally faster than traditional MITM. And what are the cons of this attack? The attacker cannot perform on-the-fly packet manipulation, which was actually possible with traditional MITM. So I'll show you a quick demo of how it works. I'm using Oracle VirtualBox, and I have 3 devices: Alice and Bob and attacker. Seems to be congested because of low resolution. Okay. Let's assume that Bob this is the Windows is Alice. Okay, Alice is a user running Windows. So if you want to know the MAC address of okay, let us say that we know that the IP and MAC address of Alice are 10.1.0.10 and 8.0.0.27 this, and the attacker's IP and MAC bindings are this two. So this is the stealth tool I was talking about, and how do you run it? It is this tool is written in PyQt for the GUI, and it is a bi-threaded application because I use only one thread for sending the packets and controlling the GUI. So it is a ridiculously simple tool, and it has pretty much obvious three buttons: stealth and semi-stealth, and exposed to Bob and exposed. I'll come to that later. And you can set in the Alice and Mac's Alice IP and MAC address, Bob's IP and MAC address, IP and MAC of the attacker. I can actually automate it, but this is, let's say, version 1. Now, let's say Alice wants to ping Bob. Okay, she's able to do that, and let's check out the ARP entries. So 10.1.0.13 is mapped to 2809, which is true MAC address of Bob. Okay. Now let's check out what Bob is doing. Okay. And the ARP address of MAC ARP table of says that Alice is bound to 75.858F MAC address, which is the true MAC address of Alice. Okay, now let's do this thing. Let's attack them. So let me auto hide it. Okay, this tool has 3 simple buttons. I mean, you can launch the attack, you can stop the attack, and you can undo the attack. It is as simple as it looks. So I would go ahead and I'll launch the attack. So this tool is based on Scapy library of Python, and it is basically written in Python. Python is ridiculously simple program, and it's my personal favorite. So as you can see, the spoof packets are sent as the way I have demonstrated in the lecture. And now let's check out the entries of Alice and Bob. Now, okay. 10.1.0.13 is mapped to broadcast address. Okay, and Alice is broadcast, and even Bob is broadcast. So essentially, the attacker can sniff into the stream. Now, let me send one AR ICMP echo or aka ping packet. I'm using Wireshark, which is a network sniffer. As you can see, 10.1, the tool continuously sends out messages that 10.1.0.10 is that broadcast and 13 is that broadcast. That is essentially Alice and Bob or it broadcast MAC address. Now let me filter it out. Okay, -10. See, so the attacker eventually got the ARP request and he got the ARP reply. Okay. Now one thing you might notice that it is showing it as lost because Windows has this particular filter that it blocks packets which it receives as from to broadcast address, and the IP and MAC address don't correspond to each other. So yeah, this can be skipped by packet tunneling through attacker. Now moving ahead. So what is the idea behind semi-stealth man-in-the-middle attack? We want to incorporate on-the-fly packet manipulation or packet tampering into stealth man-in-the-middle attack. So initially it was not possible to tamper the packets because everything was sent broadcast. Okay, so now we would like to add this packet manipulation facility into it. So I mean it's not as simple, but we have to trade anonymity with packet tampering facility. So now the trick in trading anonymity is to trade it at that point where the possibility of detection is ridiculously less. Let's say we are using in a typical organizational network, I mean in an institutional network, let's say college. So they don't bother to record all the IP MAC addresses at gateways. So you're trying to attack the gateway and a particular user, let's say Alice. So what you do is that you trade off the anonymity at the gateway, but you preserve your anonymity at Alice. Okay, so the idea behind that is that since it is very difficult that people with administrator will be coming all the way to your camp, your hostel, and will be checking at the MAC IP bindings, so it can be traded off. But Alice is a human user, and if she's suspecting that there is an ongoing attack, she can catch you or catch hold of you. So we prefer to keep the broadcast address over Alice. So what if there are two cases I would like to consider it a semi-stealth man-in-the-middle attack. One is the secure node. What I mean by secure node is that a node which drops packets with destination MAC address as broadcast. Now, in this case, we use attacker as a tunnel to modify broadcast packets as unicast packets directed to Bob. Okay. And now I'll show you this is how it looks. Now the Bob has a filter that it blocks all those packets with this strange packet format. Now this becomes simple because these packets are already filtered, and the only packets which are because this side is broadcast. Alice is sending a broadcast packet, and this side is attacker. Alice, a copy of Alice packets is captured by attacker, and the attacker can tunnel those packets through the MAC address of him. And he says that, okay, my MAC address, I'm Alice, and my MAC address is MAC address of MAC attacker. So in this way, this link is point to point as in regular stealth man-in-the-middle attack, and this is an invisible part where this is completely stealth. So when you combine these two together, we have a semi-stealth man-in-the-middle attack and this is a secure node. So even if Aleph suspects an ongoing attack, she can't do anything because broadcast is not mapped to anything. But mind you that if Bob comes to know, Bob suspects that there is an attack ongoing, he can directly catch you because the MAC address of attacker is at port 2 and it is known to the administrator. Now, what are the pros of this attack is that the attack is bidirectional and on-the-fly packet manipulation is possible. And the cons is that identity of the attacker is revealed at Bob's end. But it's okay because we are willing to trade off the anonymity. Now, what happens if the nodes are unsecured? I mean to say that there are no packet filtering rules, and the attacker can choose to expose his identity at one of the ends, gaining tunneling, tampering capacity. Hence, Bob's MAC will broadcast at Alice, and I'll show you how it looks like. Let's say the Bob is generous enough to accept all the packets. With even the strange packet formats. So what happens is that Alice sends a broadcast packet, a copy of which is received by Bob. Now, attacker doesn't tunnel the packet. Okay. Now, whenever Bob wants to reply to Alice, according to him, the Alice is located at the MAC address of attacker. So he sends that packet to attacker, and the attacker on Bob's behalf forwards the packet to Alice. So there is a kind of a circle going on here. Alice to Bob and Bob to attacker to Alice. So attacker, even now, he is able to know what is the communication going on between Alice and Bob because bidirectional stream is being captured by attacker. But he can modify only this direction of packet because when you try to modify the Alice to Bob packets, you'll be having a duplicate packet. So duplicate packets are generally dropped, and otherwise it is it is easily raised by system that since there is duplication packet, maybe something is wrong with the network, congestion and stuff. So we'll be able to modify the path between Bob to Alice. Whereas in the secured stage, we are able to modify the bidirectional path because Bob is secured, so he won't be receiving the direct packet from Alice to Bob. And another reason is that the packet from Alice to Bob will reach first than the Alice to attacker to Bob because of obvious network lag. Because it goes to Alice to switch to attacker and attacker to switch and then Bob. Whereas here it is Alice to switch and Bob. Now, and identity of attacker is the same as the previous case. There is a mistake here. Actually, it should be. Right. It is only directional, not bidirectional is possible. Okay. Now let me stop the previously ongoing attack. So it basically kills the thread which is sending the spoof packets, and you can choose to undo the packet, undo the attack. It will send 10 packets, a burst of 10 packets, refreshing Bob's and Alice's MAC addresses. So Alice and the MAC address of Bob will be set as the respective thing, and MAC address of Alice will be set as the respective MAC address. So it reinitializes the connection between Alice and Bob. So okay, as you see, when you press the undo button, the 10 packets of burst are sent to both Alice and Bob. Now I will switch over the mode to semi-stealth and exposed to Bob. It is as simple as pressing this, choosing this option, exposed to Bob and exposed to Alice. I can choose to expose which side. And now in this, when I choose the semi-stealth management attack, I need to provide my IP address and MAC address. I would have taken it automatically, but in case of systems with multiple Ethernet interfaces, it becomes a difficulty. So I, hardcoded it. So let me launch the attack. As you can see, the ARP address of Alice, of Bob, is recorded as broadcast at Alice. And that's what we wanted, because we have chosen to expose at the Bob's end. Now, Alice MAC address is recorded as 38.C0, which is the attacker's MAC address. Okay, so now in essence we are successfully showing that the Bob's and the MAC address of Alice is stored is kept as the MAC address of the attacker, and the MAC address of Bob at Alice is broadcast. Now let me stop this attack. It is as simple as pressing the stop button. Now, how do I detect the man-in-the-middle attacks? Stealth and semi-stealth man-in-the-middle attacks. It happens that these two have a characteristic fingerprint that it requires a ARP packet dictating MAC binding for an IP address to be broadcast. So, whenever you have a managed switch which has a control information, you have a centralized port where you can sniff all the data. So, whenever you find that there is an ARP packet, ARP reply or request stating that MAC address of a non-obvious IP address, non-broadcast IP address is a broadcast MAC. So that is when you know that there is a stealth man-in-the-middle attack ongoing. But even though this is easy to detect, it is impossible to know who is the attacker here. So the niche of the attack is still maintained. So for a non-stealth attack, there is a vast literature using several active and passive techniques for ARP security, as we all know. You can use active and passive techniques. There are several resources have been cited in my paper. So there are resources to detect the attack, mind you, not to find out who is the attacker. And what is the impact of it? So we have evaluated the performance in lab environment as well as on live production network with 300 plus nodes, including nodes with latest updated Windows and Linux operating systems. And that includes my own computer with Windows 7 Professional, and 300 plus node, it was my college IIT Gaudi's hostel with permission, of course. So I checked out systems with random subsampling, and I found out that in each and every system it was the same. So we can say that the attack was 100% effective. And the way to get this tool, it is uploaded at GitHub, github.com/asmagarohit/rest, and that's it. Any questions?
Yes. Where can we get your paper?
It is on IEEE Index Explore, IEEE Explore.
Good. Thank you.
One copy is provided to Nalcon, so it will be distributed along with the DB.
Okay, cool. Very good.
Yes. Why is it hard to detect where the attacker is? Because on Cisco you have a span code or a mirror code, something like that. So essentially when you detect these signature packets are coming from, which physical port they are coming from.
Yeah, that is a very particular case that we have to identify each and every packet. So you have to essentially monitoring the packet level information.
Yes. You can filter at hardware speed for ARP packets, and the signature is very easy to catch. So you can pinpoint where the attacker is sitting actually.
In almost majority of organizations we have looked at, they don't use that kind of sophistication. I mean, the maximum they go is to have a managed switch where you have IP and MAC and port bindings.
Maybe not in constant, but in corporate environments we have, in most, in Infosys at least we have this detection going on.
Okay.
If you do ARP spoofing,
Mhm.
your port will be physically shut down at the exact time the packet goes out, your switch will be shut down.
That is probably they're using ARP this techniques like
Cisco port security.
yeah. We have used Cisco Catalyst, which is for the experimentation. So they are found to be. I mean, it just shows the IP MAC and port bindings, and we have tested at our R&D facility at IITG. So I mean, that is one of the best networking rules. I mean, they don't. They say that they don't need this level of monitoring generally.
Can you say again why your attack is the real one compared to the other one?
Yeah. There is already existing literature. There is one paper in which talks about stealth management attack, which goes by the title that stealth MITM on secure channels, or a palindrome of it. So that is essentially, I mean, I found it was not exactly the man-in-the-middle attack, because what it talks is that it tries to degrade the throughput of the network on wireless network. So since there is a third person involved in successfully degrading the performance of the network, so they call it the man-in-the-middle attack, and they have uploaded it to archive.org and even IEEE. So the paper is heavily cited. So I had to call when that is not the stealth malware. This is the real one.
Okay. Any more questions? Okay. Thanks, Rohit. Rohit, you also contribute to parallel computing, grid computing, and
Yeah.
distributed computing.
Yes.
Okay. And is this your hobby? Picking into network and doing MIT?
Well, basically, I was checking out the standards of network. I mean, how does IPv4 and IPv6 work? So, this was a flaw.
With proper authority, I guess.
This actually, IPv4, this particular attack has a good story. I mean, a friend of mine challenged to attack the system, and he said that he will complain to the authority, the administrators, which are my friends, of course. So if I manage to do attack the system, so I said that no, it's not possible because I design my own tools and I know what packets are going out. He said that you think so? It's not exactly the same. There are experts there and they'll find you. I said, okay, what can I do so that my MAC address is not captured over there?
Okay. So then you did this stealth.
Yes.
Semi-stealth attacks. Okay, cool. So that friend was girl or boy?
He was a boy.
Okay.
He was my hostel mate.
Okay, fine. Thanks, Rohit.